Today we're going to talk about limits of functions. First, we need to describe what a limit is. The definition of a limit is, given a function f of x and a point x naught, the limit as x approaches x naught is L if, as x gets closer to x naught, f of x gets closer to L from every direction. L here is any real number, or plus or minus infinity. If it is one of those two things, then we say the limit exists. Kind of a pictorial representation of this definition is the following. If I am given a function f of x and some point x naught on the graph, then if I pick any point x, as it gets closer to x naught, then I want to see what the function value does as the x values approach that value. Okay. Now notice in this definition we use the word approach. It doesn't say equal to. So we are looking at what happens as we get closer and closer. Doesn't necessarily have to reach there. And again, the other part of this definition is from every direction. So it doesn't matter if I'm just coming in from the right. I could also have my x over here as it approaches x naught. And again, I'm looking at the same thing. What happens to the function value and where does it go as I approach x? Okay. There are two types of limits. There's what we call one-sided limits and two-sided limits. Okay. A one-sided limit is denoted one of two ways. Either it's the limit as x approaches x naught from the positive side, or the limit as x approaches x naught from the negative side. Okay. In these cases, we only consider what happens from one side of the equation. So either as it approaches from the right or as it approaches from the left. And so here's an example. If I'm looking at the limit as x approaches x naught from the left of the function, it means I'm only looking at values coming in from the left side, or the negative side of x naught, meaning my x has to be over here, and I'm approaching this way. Well, if my x is over here, it says my function value is going to approach this direction, and so as I get closer and closer to x naught, my f of x is getting closer and closer to b. As x approaches x naught from the right, then my x is over here, and I'm trying to figure out what happens to the function value as I come in from the right side of x naught. And so here we can see if I come in from the right side, my values are getting closer and closer to c. Okay? So this is what we call a one-sided limit. I'm only looking at the one side of the function. A two-sided limit, notice that the notation looks a lot like what we said over there for our definition. I am no longer putting a plus or minus sign here. So here I need to consider the approach from both directions, not just the right or just the left, but from both sides. Okay? So again, if I look at this picture, there's kind of two things to consider. One is this first case as I approach x naught. And again, if I look at both directions, I can see that it's going to two different things. So this tells me that my two-sided limit, because it's not going to the same thing, there is no limit there, or the limit does not exist. Okay? So the limit as x approaches x naught from both directions, the two-sided limit of the function, does not exist. The other place to consider here is something like a point x1. Okay? And so if I look at the limit as x approaches x1, again, here I'm looking at a two-sided limit, since I don't have a plus or a minus sign. So again, I want to consider what's happening from both directions. So if my x is over here, and I'm coming in this direction, or I'm coming from over here and coming from this direction, I can see that both of them are going to the same thing. And in this case, it's about halfway between A and B. So here we would say there would be our limit.